Today we're going to look at quadratic inequalities, and this is kind of weird. I made your notes packet before my collaborating teachers and I really decided what we were going to do. I apologize for that. So find in your notes packet example 2. It looks like this: x squared is less than 25. When we are solving quadratic inequalities, we need to get one side equal to 0. We're basically going to factor and solve. It's the same process as factoring and solving. So I'm going to subtract 25 on both sides so that I have x squared minus 25 is less than 0. Do you remember how to factor x squared minus 25? That's the difference of two squares, x plus 5, x minus 5. And if we were solving this, our solutions would be negative 5 and positive 5. But with inequalities, we can't call them solutions because this is not equal to 0. This is supposed to be less than 0. So these are called the critical points. And I'm using the same terminology that's used in college algebra so that when you get to this in college algebra, you'll be like, oh, critical points. I've heard that term before. The critical points are negative 5 and 5. And to figure out how the inequality is going to work with these critical points, let's draw a number line and put negative 5 and positive 5 on the number line. We are going to test regions of this number line to determine which interval on this number line has solutions to the inequality and which intervals do not. And the easiest way to do this, doing the least amount of work possible, because I know you all enjoy that, is to test a number in the middle region. So can you think of a really easy number between negative 5 and positive 5 that we could test? 0. 0 or 1. And you want to test this in the version of the inequality that has the less than whatever 0. So we're going to test it right here. So I'm going to test 0 squared minus 25 and see if it is indeed less than 0. 0 squared is 0. 0 minus 25 is negative 25. Is negative 25 smaller than 0? Yes. That means this interval contains the solutions to the inequality. We need to go back to the original symbol used. It's a less than symbol. Do you remember open circles and closed circles? A less than circle would be an open circle, and you're going to shade the region of this number line that we said yes to. If the middle is yes, this means the outside portions are going to be no. So if I tried negative 6, it would not work. If I tried positive 6, it would not work. To find our actual answer, all we need to do is take this number line picture and translate that into an inequality. So this is called an AND inequality. Negative 5 less than x less than 5. When it's shaded in the middle, it's always this format: number less than x less than other number. The symbol that you use depends on what the original symbol in the problem was. So if this had been less than or equal to, it'd be negative 5 less than or equal to x less than or equal to 5. Next, we're going to go to number 3. Very similar. We need to solve. It's not really solving, it's finding the critical points, but whatever. We need to factor to find those critical points. So we are looking for two numbers that multiply to give us negative 6. Those same numbers need to add up to negative 1. X plus 2 and x minus 3 greater than or equal to 0. We're using the solving process to find the critical points, but we need to call them the critical points. The critical points for this problem are -2 and +3. So draw yourself a number line, -2, +3. If you want to put the circles in, the open circle or closed circle, which type should we use on this one? Closed circle, because it's greater than or equal to. And what value is between -2 and 3 that we could test? 0. You can use 0, you can use 1. I think 0 is the easiest. I always write it above just so that I have a visual clue that 0 is the number that I chose to test. And we're going to test it right here. 0 plus 2, 0 minus 3. We're going to see if that's greater than or equal to 0. So we get 2 times -3. 2 times -3 is -6 greater than or equal to 0? No. So that region does not contain solutions, which means this region contains solutions and this region contains solutions. So you could even write yeses over there if you wanted to. We need to write the inequality that represents the picture we just drew. This is called an OR inequality. When the two pieces are not connected, it's called an OR inequality. You put the word OR in between them. So we've got x something -2 or x something +3. We need to decide what symbols to put in there. X is the shaded stuff. The shaded stuff is smaller than -2. So I need to put that symbol. X is less than or equal to -2. You want the symbol eating the -2 because the -2 is the bigger thing in that region. 3 is the smallest thing in this region, so we need the symbol to be eating the x. X is greater than or equal to 3. Here's the other hint. For OR inequalities, the symbol points in the direction of the shading. So if you look up here at the -2 portion, you can even see the symbol right here in the arrow that I drew. And in the 3 portion, you can see the symbol right there. All right. I would like you to try this one on your own. The first thing you need to do is get 0 on one side. So it's actually going to be x squared minus 7x plus 10 is less than or equal to 0. All of the problems I'm going to be giving you are already going to have 0 on the right side, but the examples were kind of messed up. So pause the video, try this problem on your own. Factor, find your critical points, draw a number line, test a region of your number line to decide where your solutions are. You should get critical points 2 and 5. This is the first example where we can't use 0. I mean, we could use 0 if you wanted to test 0, but 0 is not in the middle, and the least amount of work is going to be testing the middle. So I'm going to choose 3 to test. 3 minus 2 times 3 minus 5. I'm checking to see if that's less than or equal to 0. So that's 1 times -2. -2 is less than or equal to 0. So I tested 3 and it worked. That means I'm going to shade between these. Closed circle because it's less than or equal to, and I'm shading in the middle. This is called an AND inequality. All AND inequalities have x in between. Remember, x is the shaded stuff, so the shaded stuff is between the two other numbers, so that should make sense. And then less than equal to, less than equal to. My class just asked me, is it going to get harder on the next example? It looks harder, but no, it's really, really not. This is actually easier because it doesn't involve any factoring. No factoring.
You upset Jake.
I'm so sorry that I upset Jake. Okay, find this slide in your notes. It says example 1, x over x minus 2 is greater than 0. When you have a rational function, this is a rational function. Rational means fraction. This is actually a lot easier. Your critical points come from when does the top equal 0 and when does the bottom equal 0. So you want to know when does the top equal 0 and when does the bottom equal 0. That gives you your critical points. So what x value would make the top equal 0? 0. So your first critical point is 0. What x value would make the bottom equal 0? 2. Because 2 minus 2 would give you 0. That's it. No factoring, no other math. When does the top equal 0? When does the bottom equal 0? Those are your critical points. So on our number line, which I can never seem to draw straight, we got 0, we got 2. I'm going to test 1. 1 over 1 minus 2, we're testing to see if that's greater than 0. 1 minus 2 is negative 1. And 1 divided by negative 1 is negative 1. Is negative 1 larger than 0? No. So that middle portion is not part of my solution. My solution is going to be bigger than 2. What symbol should I use here? Open or closed? Open. And smaller than 0. Okay, big hint. These arrows that I drew help you with what your symbols need to look like. When it's an or inequality, oh, that's really annoying. You got x something 0 or x something 2. And these arrows show you what those symbols are going to be. If you feel like you're good, go ahead and start your assignment. If you want to make sure, give this one a try. Oh, sorry. Change this to less than or equal to 0. And then give it a try. I will pause the video. I will do this problem and then I'll show you the answer. If you are already ready to start the assignment, here's the assignment. I'll go back to the other example in a minute. So pause the video, try that example. I'll go back to it in a second. Here's the worked out example 3. Your critical points. 0 would make this top part 0. Negative 3 would make the bottom part 0. I tested negative 1 and found that it worked. So here's my picture. Negative 3 is less than or equal to x is less than or equal to 0. I had the question on the first problem. The first problem on the assignment doesn't look like one that we did. It's this. This is number 9. You need to think about when would this portion be 0? This portion would be 0. What number times 3 is 0? 0. And then when would this portion be 0? When x is 2. So your critical points are 0 and 2. Test those critical points to create your inequality.